one way to do this is to figure out the midline. It's probably, if you're writing equations for graphs that you see, you'll probably want to use that method because knowing the midline allows you to know what that vertical shift at the end of the function is. But if you were to find the midpoint between the maximum here and the minimum, so the midpoint is going to be halfway between that, right? So 10 plus a negative 2, divide that in half, and you get 4. Right? So here is our midline right here. Okay, so we know that in our sketch of, or in the equation for this graph, we're going to have a plus 4 at the end of our function. But now what you can do is just measure what's the distance from 4 to either the maximum or the minimum. Either one is, they're going to be the same thing. But what is it going to be? 6. And whatever that value is, that's your amplitude. And now if you wanted to calculate it, you could also calculate it by saying the amplitude is equal to 1/2 the absolute value of the difference of the max and min. Okay, so here, instead of finding what the coordinate of our midline is and then counting from there, you could just find what's the total distance from max to min. Well, the max to min is 10 minus a negative 2. And if you take a minus a negative becomes positive, we get 12. Absolute value of 12 times 1/2 is 6. Okay? And so you can do it either way, whatever works for you. But if you are finding the equation anyway, you probably want to find the midline and then count from there, like, because you're going to use that information anyway. Okay? So in the second example, again, from negative 2 to 4, if you find what that average is, that gives you the midline. So the midline is 1. Okay? And then you can count up from there, up 3 or down 3. Either way, that tells you what your amplitude is. And you can also use the distance, 1/2 the absolute value of the max, which is 4, minus the min, which is negative 2. That gives you 1/2 of 4 plus 2, or 6. Half of 6 is 3.